extreme value theorem. Okay, I'm going to ask a volunteer to read these 3 lines for us. Who want to read?
I disagree.
Hold on 1 second. I have not taken attendance for us, right?
No, you haven't. I disagree with the extreme value. And what happens if this is just a straight line?
Yeah, I believe there is one case about that. If it is a straight line, every point on the straight line is the maximum value and the minimum value. Okay, so I will draw the graph soon. Okay, so after a student read this part. Okay, and after we are done this video, I will take attendance. Okay, remind me. Okay. Want to read, Dylan?
The extreme value theorem. If f is continuous in a closed interval a, b, then f attains an absolute maximum value f of c and an absolute minimum value f of d at some numbers c and d in a and b.
How about this line, please?
Functions continuous on a closed interval always attain extreme value.
Very good. Okay, very good. All right, so we talked about what is extreme values. What are extreme values? Absolute maximum and absolute minimum value are all called extreme values. This theorem is telling us once we have what? A closed interval. Our given domain is on a closed interval. That means we will always attain absolute maximum and absolute minimum values. Okay, at some point, C and D. Okay, f of C is maximum and f of D is the minimum values. Okay, so just now Simon said, so he gave us some cases. Okay, so closed interval A to B. Okay, so we have a curve on the closed interval. There must be a highest point on the closed interval. Use the point on the closed interval. Yes. Now this picture, A to B. Highest point is here. Lowest point occurs at the end point. That's fine. Okay, we talk about the extreme values. Okay. This case, C closed interval from A to B. We must have a highest point. Sometimes the highest point what? The C1, C2 equals each other. Yes, they're both the absolute what? Maximum value. But you have to say f of C1 equals f of C2 are what? Absolute maximum value. Okay, so yes, A may occurs at different places, but absolute maximum value is unique because that's the highest value on the graph, right? This is f of what? F of C1 equals f of C2. However, this absolute maximum value may occurs at different x values. See, f of C1 equals f of C2 equals absolute maximum. Okay, well here it is what? The absolute minimum value. So just now Simon said, see for example we have a closed interval A to B. We have a straight line. Do we have absolute maximum value? Yes, we do. What is it? F of A equals F of B equals every single point give us absolute maximum. Yes. Okay. So I'm not gonna say absolute maximum. Okay. How about absolute minimum value? F of A equals F of B equals blah blah blah. Every point on the graph give us what? Absolute what? Minimum value. Yes. But this is a special case. Well, this theorem is telling us what? The extreme values theorem is telling us as long as we have a closed interval, whatever this graph looks like, a curve like this, blah blah blah, many curves, okay? we will always have absolute maximum and absolute minimum. Means we'll always have a highest point and a lowest point on the graph. Sometimes these points may not be unique. See, there are two absolute maximum. There are infinitely many, right? But we will have what? The maximum values or minimum values. We will, okay? You just understand this theorem, okay? I'm not going to test you about it, okay? So just know, on closed interval, function continuous on closed interval always obtain extreme values, okay? You guys, that's good? All right, the next theorem, okay, I'm going to ask some of you guys who have not answered questions, read this theorem for us, okay? Who want to read? Nick?
For Max theorem, if f has a local maximum or minimum at c, and if f of c exists, then f of c equals 0.
Okay, good. Okay, this is also an important theorem. Fermat's theorem says, well, if f has a local maximum or local minimum at value c or d or whatever. See the example. Let's look at this picture. Okay, f attain local maximum at when x equals c. Okay, f attain what? Local minimum when x equals what? D. Okay, so local maximum, local minimum. Okay, well, it says if the derivative of c or the derivative of f, this is derivative of f at c or derivative of f at d exists, then the derivatives at these points are equals what? 0. Why? Because the derivative gives us what? Slope of the line, which is tangent to the curve at these points, right? So at the local maximum or local minimum, this point, if we draw the tangent line tangent to the curve at these points, what can you see? Well, we have horizontal lines. Yes. If we have horizontal lines, what's the slope of the line? 0. So that's why f prime at c equals 0. This is f prime at d equals what? 0. Why? Because derivative gives us what? The slope of the tangent line. Remember we did this before, right? And why the slope of this tangent line equals 0? Because these points, they're tangent to the curve at what? Local maximum, local minimum values. Okay, so that's why the tangent line is a horizontal lines, right? Horizontal line give us what? 0 slope. Okay, so later, okay, if f has a local maximum or minimum at some number, okay, some number, the derivative of the function at this number will be what? 0. Geometrically, right? Geometrically. You guys do see this? Okay, we also, we have another remark, but it's on the next page, okay? So this is a Fermat's theorem, okay? I hope this is easy to understand. You guys understand this? Right? Okay, definition. Critical number. Brittany, can you read this definition for us?
The critical number of a function f is a number c in the domain of f, such that either f prime of c equals 0 or f prime of c does not exist.
Okay, very good. Okay, very good. A critical number function is a number c. Okay, when we talk about critical number, we're talking about what? X values, okay? For X value, it's not as a Y values, okay? Y value give us extreme values or local maximum, local minimum values. But when we talk about critical numbers, that's for X, okay? It's for X values. It's not for Y, okay? A critical number is a number C, okay, in the domain of the function f, such that either the derivative of f equals 0 or what? The derivative of f at c does not what? Exist. Okay, so critical numbers, okay, is this number c such that either the derivative of f at c equals 0 or derivative of c does not exist. So there are two cases: derivative equals 0 or derivative what? Does not exist. Okay, so there will be questions asking you, find the critical numbers of the given function. Why we want to find the critical numbers? Because critical numbers give us what? Once we find the critical number c, we know the graph will have what? Either local minimum or local maximum, right? Because see, when we have local maximum, local minimum, the derivative of f at c equals 0, right? So reversely, if we know we can find the critical number of the function, we know, oh, when x equals c, either the derivative of the f equals 0 give us what? Local maximum, local minimum, okay? Or what? The derivative of c does not exist. See, it says here, and if f prime of c exists, then the derivative equals 0, okay? But there may be some cases that f prime does not exist, okay? We also consider the f prime of c does not exist. It's also part of the critical numbers, okay? Such that c make f prime of c does not exist is also a critical number. What is critical number? How do we understand critical number? Important numbers. That means from the critical numbers we can get some useful information, okay? And later in the later sections of chapter 4, we'll talk about how to graph functions, okay? So we have to know critical numbers, okay? And how to find the critical number? What do? Find the derivative of f, and then either the derivative equals 0 or the derivative does not exist. Then figure out what? The c. Okay, figure out the c. Alright, so this is the definition. Let's look at the specific questions, okay? I will definitely test you in your exam 3 about how to find critical numbers of the function. Okay, so question A and B. I will need you to do both, okay, because these questions are challenging, okay? Find the critical number of this function. How? What?
The derivative?
Yeah, find the derivative of the function. Then?
Quotient rule now?
Yes, quotient rule. And then quotient rule, differentiate to the top, give us what? 1 times by the bottom minus, keep the quotient, keep the numerator, the top, and then differentiate what? The denominator, right? How do we differentiate the denominator? Y squared give us what? Negative 1 give us what? You guys? Simplify. Y squared minus y plus 1. There's no shortcuts for you, please. Minus y times 2y, y times negative 1, negative 1 times 2y, negative 1 times negative 1. Get rid of the parentheses. If something before the parentheses is negative, give up negative 2y squared. These two like terms, negative 3y times by negative 1 1. Like terms. Find derivative at first. Then in order to find the critical number, okay, so y is independent variable. In order to find the y values, okay, which is critical number, what do? Either let the derivative equal 0 or when the derivative does not exist. Now we're having a fraction. So let the derivative equal 0 will give us what? What implies what? If a fraction...
The denominator has to be 0.
Yes. If a fraction equals 0, the numerator has to be what? 0, right? Because 0 divided by anything gives us 0. So this will implies negative y squared plus 2y equals what? 0. So this is one part. The derivative equals 0. Okay. So we can have the numerator equals 0 and then we can solve for y. What's the other part? Let the denominator does not exist. For a fraction, when will the fraction does not exist? If the denominator equals 0, this derivative does not exist, right? But let's check the denominator. Will we have a 0 for the denominator? What is the denominator? What is the denominator, everyone? It is what? It is y square minus y plus 1 square, right? So, we know that for the square, it's always going to be positive with 0. So, we don't have to worry about it become a negative something, right? Something square, right? Well, if y square minus y plus 1 does not equal 0, no matter it is positive or negative or anything, the square must be positive, right? But we want to have g prime of y equals, does not exist. That means the denominator has to be 0. Can we find such a y that it will make y squared minus y plus 1 equals 0? Can we find such a y? Let's solve for it. Do you still remember the quadratic formula? 2 times a negative b plus or minus square root of what? B squared minus 4 times a times c. So this gives us y values, make this equation satisfied, right? Negative become positive, plus or minus square root of, what's negative 1 square? 1 minus 4 times 1 times 1 give us what? 4. Alright. So, 1 plus 1 minus square root of what? Can we have any real numbers y that will make this denominator equal 0? Yes or no? No way, because we have a square root of negative 3, okay? So, we're not able to find such a y that will make the y squared minus y plus 1 equal 0. That means y squared minus y plus 1 must be not equal 0. If so, the square must be what? Always positive, okay? So the denominator is always positive. So there's no such a case that the derivative of g does not exist because the denominator is always positive, okay? So we cannot find such a c that it will make f prime of c does not exist. However, we may find this c when the derivative equals what? 0. Do you see that? Okay, so negative y squared plus 2y plus 0, can you solve for y? Makes this equation satisfied? Pull the y out. So this one implies what? Either y equals 0 or y equals what? 2. You guys, everybody? Okay, so we say the critical points for this function g are what? When y equals 0 and when y equals what? 2. Okay, so you can answer the question, say critical points, okay, critical numbers are when y equals 0 and what? Because when y equals 0 or y equals 2, it makes the derivative equal 0. And that satisfies what? The definition for the critical numbers. And we cannot find such a y, real number y, which will make the denominator equal 0. So we do not have that part, okay? So these two are the critical numbers. Any question about this question A? So if we summarize how to find critical numbers, what do we do, guys? Find a derivative of this function, right? And then if the derivative function is in the fraction way, let both the numerator equal 0 and the denominator equal 0. Why? Because denominator equals 0 give us what? The derivative does not exist, right? So find a derivative, and then if it's in a fraction way, let both the numerator and denominator equal 0, solve for the corresponding x. That will be our critical numbers. You guys? Alright, so let's try the next question. We have a fraction as exponent. So that's the hard part. F of x equals this. So find critical numbers. What do we do at the first? What do you do? Differentiate it, right? So find derivative first, okay? Alright, so differentiate f. How, everyone? Is this the product? Yes. Or we can use product rule, right? Or can we simplify this f at first? Can we follow the x minus 4 square, then distribute x to 4/5 to, can we do that? We can also do that, right? So either way, you can find a derivative directly by product rule, or we can simplify first, okay? I'm going to try to simplify first, okay? Because before I came here, I tried by using the product rule directly. But now I'm going to try to see whether we can use a different way to do it, okay? So let's follow the x minus 4 square. Give us what? Do you see this, everyone? Just follow that. Distribute x to the 4/5 plus 2. Four-fifths plus 1, 9/5, 16, x, 4/5. You guys? Now I'm going to compute the derivative, okay? I'm going to write it here. Keeps on telling me something. Okay, so the derivative of f is going to be, use what? Power rule, right? Power rule. So power rule tells us 14 over 5 x to the what? What's 14 over 5 minus 1? 9/5, right? Minus 8 times by 9 over 5 times by x to the what? 4 over 5, right? And then plus 16 times, this is all power rule, right? See, you're okay for this step or not? Power rule, right? Alright, now we're going to simplify, okay? So see, for the coefficient, everybody has a fifth, right? So I'm going to pull the fifths out. So 1/5 to everything, okay, to everything. So what are the everything? 14x to the 9 over 5 minus 8 times 9, 72, right? So actually you see 14, 72, 64 has a common factor, what? 2, right? So 7, because 2 times 7 gives us 14, right? This 5 is out on the bottom, and then we divide 8 by 2 give us a 4. 4 times 9, 36. X to the 4 over 5. This 5 is out. We must also have a 2 out, so 16 times 2, 32. You guys, it was good? Everyone? See?
What is this about 4 divided by 2?
Because this is 8 times by 9 over 5, right? This 5 is here, right? And then I pull the 2 out. So that's why it should be 4 times 6. You see, this is 2 out. It's not 1, right? So that's how we get 36. Here, you see, 5 is here, and then because there's 2 out, so it's not, we don't have 14 here, we have a 7. This one, same thing, 5 is out. 4 times 16, there's 2 out, so divide 4 by 2. So 2 times 16 gives us 32. Okay, see, everybody, we have x to the 9 over 5, x to the 4 over 5, x to the negative 1 over 5. Not even one exponent is an integer. How can we do it? Okay, guys. X to the negative 1 over 5. I'm going to pull this part out and see what we can get. Okay, so 2 over 5 right. I'm going to pull this term out. So 7 times by x to the what? Such that this exponent plus negative 1 over 5 equals positive 9 over 5. We draw a negative 1 over 5 out. What? Can you please check? Is negative 1/5 plus 2 equals 9 over 5? Yes. You will see very soon, okay, why I'm putting the negative 1 over 5 out, okay? Well, this term, negative 36, x to the what times by x to the negative 1 over 5 equals positive 4 over 5. One, right? Because if we're putting a negative 1/5 out, we have to add the 1/5 to the exponent. Add the 1/5 to this exponent give us 1. And if we put this x negative 1 over 5 out, there's no this term anymore, so plus 1. So we do. Okay? And then why we're factoring? Because eventually we want the derivative equal 0 or denominator equal 0, right? So we have to factor, right? We need to factor. So I'm going to put the 2 over 5 here. This x to the 1/5 can be written by x to the 1/5 on the bottom, because this is negative 1, right? Now, are we able to factor the 7, negative 36, and then 32? Are we? We can factor the 7x squared by x 7x, and then I'm going to factor the 32 by a product of what? I don't know, but it will make the middle term, this coefficient is what? Negative 36. Will this work? Negative 28 minus 8 equals negative 36. Yes. Well, trial and error. You may put a negative 8 here and negative 4 here the first time, but when you check, you may not get a negative 36, so you have to try.
Isn't it method factor by grouping?
Yeah, you can, grouping, it's not by grouping, it's called trinomial factor. We learned this in college algebra, right?
I think so.
Yeah, so you have to review for the college algebra. It's not by grouping. For grouping, you only have 4 terms, but there are 3 terms. So it's like a trinomial, right? Trinomial means 3 terms. 3 terms factoring, okay? All right, so you want to review if you forget. That's fine, okay? All right, now we're very happy. See, the derivative of capital F is like this, right? So in order to find the critical numbers, what do you do? Let the derivative equal 0, or let the derivative what? Does not exist, okay? So is this form in the fraction way? Yes or no? Yes, okay? So to let the derivative equal 0, the numerator must be what? Equal 0. So that means this factor should be 0, this factor should be 0. How about when the derivative does not exist? The denominator must always also equals what? 0, okay? So we're going to let x minus 4 equals 0, 7x minus 8 equals 0, and what? See? Every possible factors on the bottom and on the top and the bottom, we must let them equal 0 to get the entire derivative equal 0 or undefined, right? Does not exist. So we have 3 equations. Let's solve for the x values. X equals 4 is 1, right? 7x minus 8 equals 0, x will be what? 8 over 7th. What value x will make the 5th root of x equals 0? Well, x equals what? 0. Right? So, critical numbers are what? 4, 8 over 7, 0.